Welcome back. So plates move. How they move relative to one another is they do so in a few different ways, all driven by mantle convection. Again, that hot mantle material rising up, hot Play-Doh mixed with rock. It's very sticky stuff, so it grabs onto plates, pulls them apart, crashes them together, rubbing them side by side. So the mantle convection drives the movement of plates, which we know they move. But they move relative to one another in a few different ways. So where different plates meet, this is a little bit different than talking about crust, because plates could consist of all continental crust, all oceanic crust, or most likely a combination of two, oceanic and continental crust. We're not talking about that. We're just talking about where these large plates, which could be any type of crust, meet and interact somehow with another plate. The first thing that plates can do is collide. So mantle convection can actually take two plates and start to crash them together. That's called a convergent boundary, where they're coming together, they converge, they're colliding. So two plates are moving towards each other. Sometimes it's known as a subduction zone because, well, one of the plates usually gets subducted, pushed below the other one. They got to go somewhere. So they're going to crash together. They don't just keep crumpling up. At some point, one of them is going to get pushed down underneath. So sometimes called a subduction zone. There's three different types of convergent boundaries, but just know that convergent, collide. When plates collide together, convergent boundaries. You have divergent boundaries. So to diverge means to pull apart. So this is where plates are divided, moving apart from one another. Two plates move apart from each other, sometimes referred to as a ridge, like a mid-ocean ridge, a rift, continental rift, often on continental crust, or sometimes just generally spreading centers. This is where the mantle convection is kind of pulling plates apart. As they're being pulled apart, that hot mantle material slowly makes its way up, cools to create new crust. And then you get transform boundaries. So sometimes they collide, convergent boundaries. Sometimes plates pull apart, divide. Those are divergent boundaries. Sometimes plates actually move side by side. Instead of apart or towards, they actually move side by side. Those are called transform boundaries, when they're sliding past one another. They're moving horizontally past each other. Each different type of boundary will give us different types of hazards. Not only different types of hazards, but different severity of hazards as well. Convergent boundaries being the nastiest. If you live near a convergent boundary, places where plates are crashing together, that's the dangerous place to live. Same with transform boundaries. As plates are grinding past one another, that can be a dangerous place to live. Oops. Yeah, I'm sorry. I was hoping I didn't skip ahead. So here is a map of the world broken up into some of the larger plates. So most of the United States and Canada, Greenland, and most of Central America is on the North American plate. Part of California is actually on the Pacific plate, which is a big plate. It's underneath the Pacific Ocean. South America is on the South American plate. There's a Nazca plate over here, the Cocos plate, the Caribbean plate, the Eurasian plate that most of Europe and Asia sits on. The Indo-Australian plate consists of India, Australia, and the ocean. The Antarctic plate. So these are just a number of the major plates. There's a lot of tiny little ones kind of around as well. But what these are showing you are the different types of motion at these boundaries. So for instance, the North American plate and the African plate, they are moving away from one another. They're being split apart. This little blue line indicates a divergent boundary. So the plates are being moved apart. That's where the mid-Atlantic oceanic ridge runs this whole line. This is all a divergent boundary through here. But for example, look at the Nazca plate. The Nazca plate and the Pacific plate are spreading apart. So divergent boundary. But that's causing the Nazca plate to crash in, to move to the right, while the South American plate is moving to the left, because of this divergent boundary, but what that's causing then is the Nazca Plate to collide with the South American plate. So you get this red line with triangles called a convergent boundary. Convergent boundary. And then you have a kind of just a solid blue line, which represents a transform boundary. These happen in a lot of cases in little smaller regions of plate boundaries. One famous example is in California along the San Andreas Fault. The Pacific Plate in this area is kind of moving northwest relative to the North American Plate moving southeast relative to one another, not overall, creating this side-by-side motion. Okay. So, I kind of told you and gave you the hint, convergent boundaries a little bit more dangerous to live by. Transform boundaries. Divergent boundaries, not so much, only because you don't see too many of them on land. There's a famous divergent boundary right along Africa, creating the Rift Valley. Maybe you heard about it, Disney movies or whatever. So what natural hazards could be created and or affected by the plates moving? So let's take a look at this map again. So this is the plate boundaries. I'm going to flip between this map and this map. The blue dots indicate areas where there's been historic earthquakes. The red indicate areas where there's been historic volcanoes. All right. Kind of pick a boundary. All right. Let's say let's pick this whole divergent boundary through the Atlantic Ocean. I'm going to flip back and forth. All down. Oops, went too far. All right, so we see a lot of blue dots. So along divergent boundaries, we get a lot of blue dots, a lot of earthquakes. I didn't say a lot of earthquakes. We get some earthquakes. All right. Where do you see more blue dots? For instance, right here along South America. Not only are there a lot of blue dots, but there's also a good amount of red triangles, volcanoes. Let's go back. What kind of boundaries over there? Ooh, a convergent boundary. Let's see, where else are there convergent boundaries? Up here by Alaska, a lot of earthquakes, a lot of volcanoes. Oh my goodness. What about over here in Asia? Let's see, where kind of Japan is. Convergent boundary. Let's see here, earthquakes and volcanoes. Huh. So, divergent boundaries, example here, or look, here's another divergent boundary. So you get some earthquakes at divergent boundaries. But you get a ton of earthquakes at volcanoes, or a ton of earthquakes and volcanoes at convergent boundaries. And then what about transform boundaries? A lot of earthquakes. A little bit more concentrated even than divergent boundaries. So divergent, you can get some earthquakes. Transform, you definitely get concentrated earthquakes. Convergent boundaries, bunch of earthquakes, a bunch of volcanoes. Now, earthquakes and volcanoes can happen away from plate boundaries. It's not the only place that it can happen. But just in general, living near a plate boundary, specifically convergent, transform, then divergent in that order, living near a boundary can be dangerous, can be hazardous in regards to volcanoes and earthquakes. So, convergent boundaries, this is where plates collide. It's a very destructive force where crust is crumpled and destroyed and something is pushed down back into the mantle and melts over again. The topography that we typically see at convergent boundaries, mountains, things get mounded up, volcanoes, oceanic trenches. There's many, and there's volcanoes, they're many and powerful, and yes, there's earthquakes, many and powerful. Convergent boundaries. Transform boundaries, kind of next on this list. This is where the plates kind of slide past one another. It's a conservative force in that crust is neither created nor destroyed. It just kind of grinds past one another. There's no major topography effect. Topography means like the terrain, the shape of the terrain. Things are sliding past one another, but it's not really making mountains or anything. It's just kind of sliding past one another, for the most part. You don't really get volcanoes, but yes, you get earthquakes. You get many earthquakes, and they're very powerful, because as these plates move side by side and grind, every time they move, that energy is released. That's an earthquake. When convergent plates collide, as they're colliding and they're moving, things are cracking, snapping, crashing together. Earthquakes, but volcanoes as well. And then divergent boundaries, kind of third on the list of if you kind of rank them by dangerous or destruction. This is where plates are moving apart from one another, dividing. It's kind of a constructive effect because crust is created as plates are moving apart. That hot mantle material kind of fills in that void to create new rock, new crust. You can get ridges and rifts, spreading centers. The topography that's created. Most of those, again, under the ocean. Some, for instance, the Rift Valley on Africa. Can you get? Let's deal with earthquakes. Yes, you can get earthquakes, but they're kind of few and far between, and they're actually relatively weak. Right, they're relatively weak. When we're going back here, like for instance, a divergent boundary. Yes, there are some blue dots here, but those are kind of few and far between. They're relatively weak earthquakes, but stuff is moving, so earthquake nonetheless. And same with volcanoes. When you're moving apart, materials coming up in some places, again, going back to this map, you can find volcanic activity near a divergent boundary. But again, that's few and far between, and that's relatively weak. Powerful volcanoes, convergent boundaries. A lot of them and powerful. No volcanoes transform. So, I guess in list of most to least dangerous, convergent, transform, divergent. So we'll start talking about in the next few units volcanoes and earthquakes, and a lot of those conversations will revolve around convergent boundaries, some transform boundaries, not too much around divergent. But again, you can get some random earthquakes and volcanoes not on a plate boundary. That's where most volcanoes and earthquakes happen, where the plates interact. But for instance, look at kind of the central or eastern portion of the United States here. You can still get, random earthquakes. Hell, even a random volcano out there. So it does happen. But mostly around boundaries, that's where you're going to find earthquakes and volcanoes. Depending on the type of boundary, it depends on the severity of volcanoes or earthquakes. So we're going to pause here. Before we go, let me give you the super secret code. It is the number 5555. You got me? 5555. 4 5s in a row. All right. When we come back, we'll kind of talk about how all of this comes together to create something called plate tectonic theory. Be careful with that word. Plate tectonic theory. See you back here in just a second.